और कनिष्का तुमने क्या किया दशहरे पे? डिड यू एंजॉय? अच्छा हरिप्रिया, डिड एट योर प्लेस डू दे मतलब डू दे सेलिब्रेट दिस दशहरा एंड ऑल? नॉट
Sir,
बचरा?
Mysore Dasra is
दशरा?
famous. Mysore Dasra.
व्हाट? आई कैन अंडरस्टैंड.
Mysore Dasra.
अच्छा मैसूर दशरा. अच्छा अच्छा. व्हाट दे डू देयर?
Sir, it's a procession where uh, Lord Chamundi is carried throughout the city on an
जस्ट.
elephant.
अच्छा अच्छा अच्छा, दैट वन ना. एंड फेयर्स आल्सो दे कंडक्ट.
Ah, yes, sir.
Here it's different one. Here also fair is there, but they do different kind of worship and all. Every home is different kind. But usually the Ram and Ravan, the Ram Bhagwan, he came to home na, on that day. Mhm. He killed Ravana on that day, on this day. That celebration they do. And do they burn this Ravan there?
No, sir. For us, it's the killing of Mahishasura by Chamundeshwari.
Mahishasura. Hmm. See, same day they celebrated different styles. Acha, this question that I gave, you could solve this now. You have solved it on that day only.
Yes, sir.
Hmm. Acha, let me start with this one. Combination we were doing. And the combination part, this basic definition I have told you. Formulas based on that also we have done. Now let's move on to the next part. Acha. Try solving this one. Basic handshake type of questions and all you will be able to do very easily. I'm not giving very easy questions. Try solving this.
Option C.
Option C, no.
No, 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 C. It's none of these.
No. They're saying it's A.
There should be and no sin, not or.
Wait. Fill, when and is there, you have to multiply, na? For or you have to add.
Okay, there is an option.
It's silly mistake. What about Kanishka? Kanishka, तुम्हारा आंसर आया?
Sir, it's B.
बी नहीं, बी नहीं है इसका आंसर ए ही है। और मैं तुम्हें बताता हूँ कैसे है तुम लोग को। To fill 12 vacancies, there are 25 candidates, of which 5 are from scheduled caste. 3 of the vacancies are reserved for scheduled caste, the rest are open to all. अच्छा, there are 12 vacancies, 25 candidates, 25 candidates of which 5 are SCs, means the 20 are normal, other. Out of these, 3 vacancies are for SCs reserved, rest are 9. So these, now from these vacancies, there are 5 persons, 5 seats, 5 candidates can be filled. We have, out of 5 candidates, we have to select only 3 to fill these 3. Rest are 9. Now this can be done in 5C3 ways. We have to select any 3 out of 5 to be filled for SC, because at place of SC you can just put SC candidates only, you cannot put other candidates. That's why 5C3. The rest, how 3 are filled. Now how many are remaining? 20 plus 2 here who are left. 2 SCs will be left anyway. So 20 plus 2, 22. 22 are left. And for 22 we have to select only 9 places, because 9 candidates we have to select for remaining 9 vacancies to be filled out of these 22 persons. So 22C, 9. Now we can fill these vacancies if we use AND, because filling of 3 vacancies and filling of 9 vacancies will give us filling of 12 vacancies. So it will be 5C3 AND means multiplication into 20C9. You cannot do minus. Okay. Kanishka, okay? Easy? Understood?
Yes, sir.
Minus is out of picture. You can, you have to be very careful about the using of your fundamental principle of counting. When you are adding, you have to, when you are adding means there should be OR in your calculations. When you are multiplying, that means it's AND. And AND is used whenever your work gets completed by taking both the cases. You are doing this work and doing that work. Combination of both gives you the result. And the other thing is, your work gets completed either if you do the one work, then also your work gets completed, or if you do the second work, then also your work is getting completed. In that case you can use OR, that's adding. That's fundamental principle of counting. Now see, these kinds of questions you can do. Acha, let me give you one more question, then I'll give you different kind of different concept. See, these competition, these things you are doing, these kinds of combinations you are doing when there is no repetition involved. When the repetition is involved, na, in that case things go different. That only we are going to discuss now. Just try to solve this question that I'm giving. After this, we'll do that. Are you getting the answer or not? Haripriya, getting answer?
One minute.
No, not getting.
1 minute I'm doing it.
Acha, do it, do it.
So could you do it?
Kanishka का भी नहीं आ रहा क्या? Kanishka
Sir,
also.
I am solving.
Acha, you solve. Okay. See what they have said. How many words of 4 consonants and 3 vowels can be formed from 6 consonants? You have to make a word of 4 consonants and 3 vowels. There are 6 consonants and 5 vowels. So 4 consonants out of 6 can be selected in 6C4 ways. And out of 5 vowel, out of 5 vowel, 3 vowel can be selected in 5C3. This gets done in 6C4 into 5C3 ways. But they are asking how many words. Words are not formed by just selecting the consonants and vowels, because the consonants are different. Every consonant is different. Every vowel is also different. A, E, I, O, U. So you will have to rearrange them in all possible ways.
Then you get 15 and 10 respectively.
Huh?
For consonants, you get 15 ways of selecting, and for vowels, you get 10 ways of selecting.
Excuse me, sir.
Ah,
Sir, is the answer is option B?
correct. Right, option B. What? Harpreet, I did not get you. 64 into 5C3.
No, that was 64 was 15 and
But
5C3 was
okay. 5C3 is what?
10.
Okay. Now the remaining thing is, now these 7 words can be interchanged to form a number of this one words. This can be any 7 factorial ways. So your answer should be 150 multiplied by 1 into 2 into 3 into 4 into 5 into 6 into 7. If you multiply this, you should be getting 756000. But I think, Haripriya, you should have got 64 into 5C3, but you did not multiply with 7 factorial, right?
Yeah.
Because number of words are out, no? That's right.
I divided like 25 to 7.
Mhm.
I didn't multiply 7 factorial.
That's what I understood. What mistake you'll do. And you both took time, and that time was 7 factorial only. Okay, now let me tell you about, see, these things we were doing were actually number of combination with no repetition. Means what we are what I'm saying with repetition means, once we have selected an object, we cannot reselect it. That's the problem. Here in this particular case, the earlier cases that we were dealing, there once we have selected an object, we cannot select it again. So reselection is not there. No repetition. But now the cases that I am giving you, these will be used when number of selections you have to do with repetition involved. With repetition and all possible selections. Means all possible selections with repetition involved, no repetition involved, all the cases we have to count. So how do we do it? First formula I'm giving, number of combination of when any object can be repeated any number of times. See, here the case is, you have to select out of n distinct objects, take an hour at a time. You have to select out of n distinct objects, take an hour at a time. That's simply, that becomes NC3, NCR. But here the case is different. Here any object can be repeated any number of times. So what's the answer is for this? The answer is coefficient of x power r in 1 plus x square plus so on and so on up to x power r whole power n. Why we are doing this one? Why we are taking x power r? Because see, any object, why we are doing this thing, for each object, if I have to select r, means I have to select r things, r object out of the particular, first let me tell you about the total number of possible cases that are possible. See, for each object, if one object I take, I can take it, I can not take it. That means I have not selected that, not used it in my selection. That's x power 0. Or I can use it x number of times, or the one time I can use, or I can use 2 times. That object I can use 2 times for selection of R objects, or the same object, because the repetition is allowed, I can use it up to R times, not more than R, because there are R objects only I have to select. But the problem is the single object, because repetition is allowed, the single object can be used 1 times or 2 times or 3 times or not used, or it can be used R times for the selection of R objects. Okay? Correct, Haripriya? Correct, Kanishka? Okay?
Yes, sir.
Okay, sir.
This is for each object, that possible selections. Now there are n different objects. So what my possible all kinds of selection that I can do the sample space for each object is this. So I can make 1 plus x square plus and so on. I am using plus here because there is or involved. I can use one object, I can never use it, or I can use one object 1 time. I can use one object 2 times for selecting R objects, or I can use one object three times, means selecting one object 3 times. Selected one, again placed it, again selected, again placed it, again selected, like that. So similarly, the same thing I can do with all the n different objects. 1 plus x square, so on and so on, x power r, and 1 plus x square, x power r. This I can do for n object. This is 1 to n times. This is for each object. This is first object, again for second object, for third object, for nth object. Now this becomes, now my sample space becomes 1 plus x square up to x power r whole power n. Now out of these all possible sample cases, I have to select any r things, r objects only, means I have to do the selection of r objects only. So I will have to take the coefficient of x power r. Coefficient of x power r means it signifies selection of R objects out of these all sample cases. You understood now? This thing happens because here we use repetition of objects. Means how repetition of objects? When I have selected one object, I can place it again in the case and then again use the same object for the next selection. That's the problem here. But in the earlier cases, when we used to do the earlier cases calculation that we were doing before without repetition, once we have selected an object, we can never place that same object in the lot, and then again we cannot use the same object for the next selection, because once we have selected an object, that goes out. Okay, that's the difference between that case and this case. Understood? First formula. Haripriya, Kanishka, okay?
yes, sir.
Yes, sir.
This is not easy, this is a bit difficult one. So you have to understand it properly. Now the total number of ways, second formula is total number of ways in which it is possible to form groups by taking यार है Sum or all of n things at a time. That formula is 2 power n minus 1. Total number of ways, first understand this. Total number of ways in which it is possible to form a group by taking some or all of n things. Means, what's this case now? He has said you have to take some or all things. Means there are n different things. Out of that, you can select either one, you can either select no object, or you can select one object, or you can select two object, or you can select three object, or you can select four object, or you can select n objects. But he has said you have to take some or all n things. At least you have to, what he is saying by this line, you have to at least choose one. But this case signifies that you have not selected anything out of n different objects. Okay, so that means this case I have to minus. So that's why my answer will become NC1 plus NC2, or this is what, NC0 plus NC1 plus and so on up to NCn minus NC0. But this you will be knowing that in binomial theorem we say 1 plus x whole power n is equal to NC0 plus NC1 into x plus NC2 into x square plus NC2 into x cube plus and so on up to NCn into x power n. So when you want the sum of these things, only coefficient you put x is equal to 1. You get 2 power n is equal to NC0 plus NC1 plus NC2 plus and so on up to NCn. That's why this formula, this value is 2 power n, and this is actually 1. So that's why you get 2 power n minus 1. I'm proving it for you to just understand. But actually, in reality, if you just remember this formula, it will work for you. I'm just showing you how we are getting this answer. Okay? Easy? Understood? Haribhai, okay now?
Yes. But why did you substitute x is equal to 1?
Yeah, because we want this value now. We want this sum. NC0 plus NC1 plus this sum we want.
So in general, this.
In general, if n value will be small, you need not have to substitute the value. Or you can take lesser values, but then also this formula will actually make things easy for you. Because in binomial theorem, see, either the ways are either you keep on calculating NC0 value, NC1 value, NC2 value by using your factorial notation, n factorial by r factorial by into n minus r factorial. That way you calculate each term, then do the sum. That's the one thing. Okay, that's one thing. But other thing is you make use of this formula because we know binomial theorem, and in binomial theorem you will learn this one, that the sum of the coefficients of binomial coefficients, you get this value when you put x is equal to 1, because this is the actual binomial theorem, This is actual binomial theorem.
Okay.
With one coefficient taken as 1, one number taken as 1. That sum of that you will use when you will get sum when you put x is equal to 1. So you will get NC0 plus NC1 plus NC2. So this value you can just directly put it here, so the formula becomes easy. But you are free to use. You are free to calculate using that method also. Whatever you feel easy, you can use it. Let me show you the third formula then. Third formula is the total number of ways in which it is possible to make groups by taking some or all out of n, which is equal to n1 plus n2 plus n3 plus and so on up to things. Now here they have made groupings in the group also, means there are n different objects of which n1 are of same kind, n2 are of different kind, n3 are of different kind, like those things, where n1 are alike, n2 are alike, this formula is n1 plus 1 into n2 plus 1, so on and so on, minus 1. This different calculation in which you have to do the selection for the total number of selections are you will make is you will do 1 plus x whole power. What you will get is so you have to make groups only. This is just group making. Okay. This is just group making. So out of the total number of this just calculation of sample space, there are n1 things. Either you can the selection the group that you can make is out of the n1 object plus 1 that we are counting here is of the no case, means n1 objects are not taken only. So n1 objects are there plus no object is taken. That case we are counting as 1. So the grouping is can be made by n1 plus 1 into for n2 plus 1, like that. Those cases it's just group making. Group making is easy on. You have to just remove that case in which there is no means in the group there is no element only, all 0. That case you have to remove, because in the group there has to be at least one object. At least means there should be one object at least present. It's just group making. It's easy only. Understood this one? Group making is there are n1 object. Here you are adding 1 because you are taking the case in which n1 objects are there, and one case you are adding because taking the case when no element where in the selection in the making group, in the making of group, you are not counting an n1 object only. You can make the groups, make the group of any objects. R object means these object selection they have not told us, just to make the groups they have given. The total number of groups you can make is by selecting n1 objects, taking n1 objects, or not selecting any one of them. That is counted as one. So for every different kind, you can make these things, group making, and then multiply them. So total, all the different types of groups, all the total number of groups that can be formed. And this -1 we have removed. So that case in which 1 into 1 into 1 into 1 is there, in which you have not selected n1, any any number from n1, any member from n2, any member from n3, all those selections you have omitted. That counted as this one. So that one you have to remove. So because in the group there has to be at least one object. It's just group making again. Understood? It's easy only, it's not difficult one. This is again easy. The fourth formula, the number of selections are objects out of n identical objects. Identical objects means you can do it in one way only. All are alike, na? This is easy. 5 is number of selection of 0 or more objects out of n identical objects. This will be n plus 1. 0 means that will be counted as 1, and one object we can select in one way, two object we can select in one way only, three object we can select in one way only. So the total n objects again 1. क्या हुआ Kanishka? Is there is some net difference, internet problem I think with Kanishka. Kanishka, you are facing some network issue, na?
No, sir, by mistake it happened with me twice. Like, I'm just even sometime I was zooming in and out by mistake. I don't know how suddenly like the app was getting closed. It was
Oh,
my fault.
okay. Now, let me give you one question now. There is one more formula that I'll tell you later, but let's solve some question now. Try solving this.
2 power 10.
2 power 10. No, you, I think, forgot to do -1. You did not do -1, no? Help me out?
Sir?
Hmm. You did not do -1, no?
Yes, sir. I was overconfident that it was 2 power 10.
In that case will be 2 power 10 is the total ways in which you can illuminate, because each lamp, there are 10 lamps. Each lamp can be either on or off. That's 2 ways. So 2 into 2 into 2 into 2 into 10 ways. So it will be 2 power 10. But there will be one case in which all the lamps will be off. In that case, when all the lamps are off, your hall won't be illuminated. That you have to minus, because that case we do not want. So your answer is 2 power 10 minus 1, which is 1024 minus 1, 1023. कनिष्का ओके, आंसर आ गया?
ओके सर। नहीं सर, थोड़ी कंफ्यूजन हो गई।
कंफ्यूजन हो गई? अभी समझ में आया कि मैंने समझाया?
यस सर।
See, that's why I actually explained you every case. The formulas that you got na earlier, I explained you every case, because it's not necessary that every time you will be using the formula to get the answer. Rather than that, you actually use your reasoning to get the answer. Try solving this. we getting the answer? At least one letter is repeated, he's asking, na? It's very easy actually. Let me solve quickly for you. Or do you want yourself to solve? See, how we'll be solving it now? Let me show you. See, solution to this will be 10 power 5, because 10 different letters, 5 ways, all possible cases will become. Out of these, you have to select at least one letter is repeated. Means you have to minus those cases in which no letter is repeated. And when no letter is repeated, those cases are 10C5. Yes, na? So 10 power 5 minus 10C5, you should get the answer. That 99748. B. Okay, Haripriya? Okay, Kanishka? Understood now? These are all cases with repetition. These are 5 words, 5 letters without repetition. Because without repetition is required, we do not want repetition cases. So without repetition case, we have to minus. Okay, let's end it.